Ever since I've started watching spy movies, I've developed a curiosity of how undercover operations are carried out using technology and complex devices. One such device is the listening bug or the covert listening device, through which one can hear the conversations and sounds from another room or from a very far away place. When I researched on this topic, I realized that it used the operational amplifier IC741, which was also taught to us during the ELP course, and hence I chose this topic. Starting from the circuit diagram from the listening bug, I'll start from the very first component, which is the microphone. The microphone here acts as a transducer, thereby converting the audio signal which we receive at the input end into voltage. We realize that even after this conversion, the value of the voltage is in millivolts and hence it needs further amplification, and hence this whole circuit device was built. With the help of the condenser microphone being used in this circuit, the sound waves from about 6 meters can be converted into electrical signals. The circuit, as shown in the figure, has been divided into 3 sections. Part 1 is the receiver end of the circuit, which consists of the electronic microphone, resistor R1, resistor R2, and capacitor C1. The microphone converts the sound into electrical pulses, as explained before. R1 is used to adjust the sensitivity of the mic. R2 serves as volume control for the circuit, and the capacitor C1 is used to remove the DC component from the signal. The part 2 of this circuit is the preamplifier. The preamplifier stage was built using the op-amp IC741. This integrated circuit was wired as an inverting amplifier here, and hence the input signal was passed through the inverting terminal of the IC741. The positive terminal of the non-inverting part was biased using the voltage divider R3 and R4. R5 resistor was used to provide negative feedback for the op-amp, which in turn changed the gain of the op-amp. The use of op-amp as an inverting amplifier is as shown. This arrangement is named as inverting because it amplifies and reverses the polarity of the input signal. The gain of the op-amp can be shown as V output divided by V input is equal to minus RF divided by R input. The negative sign indicates that the polarity of the output waveform is reversed. Therefore, by adjusting the values of RF and RN, the desired amplification can be achieved. Talking about the connections of the op-amp IC in the circuit, a wire is connected from the microphone to the pin 2, which is the inverting input of the op-amp. It is connected through the resistor R2 and the capacitor C1. A pure DC power supply of voltage 9 volts to 15 volt is connected to the pin 7, whereas pin 4 is grounded. Talking about part 3, which is the amplifier stage of this circuit. It is built using the 2 bipolar junction transistor. Both these transistors are connected in a push-pull configuration, which means one of the transistor amplifies the positive half of the input signal while the other deals with the negative half. Thus, we obtain an amplified 180-degree out-of-phase signal from this push-pull amplifier. We saw that from op-amp, which is the preamplifier stage, we also got an inverting signal. Here, the signal was again inverted, and hence the original signal and the final signal obtained after these 2 stages are in phase with each other. The signal is then passed through the capacitor C2 to filter out any DC components again, and it is again finally passed through the loudspeaker. Talking about the complementary pair transistor, push-pull configuration states that one of them is of the NPN form and the other as a PNP form. The output of the op-amp, which is obtained at pin 6, is given to the base of these transistors named as T1 and T2. There, the complementary pairs are there to provide more power to the speaker. Output from this integrated circuit is again amplified from the push-pull amplifier of the transistor pair. Before proceeding further, I would like to reflect upon the passive components such as resistors and capacitors and their functions. The voltage divider network is formed using two 10,000 ohm resistors, which is R3 and R4, in order to set the reference voltage at a non-inverting pin of the op-amp. The feedback network of the op-amp, which consists of the resistor R5 and the variable resistance R1, is shown in the figure. The gain of the operational amplifier can be changed by varying the feedback, as we saw in the formula for the gain of the op-amp. Capacitor C2 again is used to filter out any DC component if it is available. Finally, coming to the loudspeaker, this amplified voltage signal is again this voltage signal is converted to sound with the help of this loudspeaker device, which is the last part of this circuit. These are some of the practical values which I got while I was researching on this topic. We can see that the capacitors used in this circuit are of various types. C1 is of the ceramic type, C2 and C3 are electrolytic type. The resistors which we used were of the order of kilo ohms. We used a condenser microphone, and the loudspeaker which we used was a 4 ohm loudspeaker. So this was how the listening bug functioned. Thank you.